Day 2 on the theorems and zeros of polynomial functions. Today we're going to work with imaginary values. So on here it has if a complex number a plus bi is a zero of a polynomial function with function f(x) with real coefficients, then its conjugate a minus bi is also a zero. So they gave you an example here. If 2 plus 3i is a zero of f of x, then 2 minus 3i is also a zero of f of x. This is where I get to remind you where those come from. Even the square root of -1 is equal to I, and I squared is equal to -1. Square this, square the radical, disappear. I cubed is equal to I squared times I, and I to the fourth is +1. This is going to come in handy. This is the one you'll use the most. I should never have an exponent on it. You should always be able to get rid of that exponent. Okay, so let's look at what they're telling us to do on these ones. Find a polynomial function of degree 3 with given number of zeros. They gave us I, -I, and 2. Now, remember I told you this is the way you go through and do these. When you have I, it's a little bit different. So the 2 is the same. That is just x minus 2. But these ones, remember, they're conjugates. They go together. So really what we have is x equals plus or minus I. And to get rid of this, we square both sides. So I really have x squared equals I squared. But I squared, I had just given you, is -1. And if I add 1, that gives me x squared plus 1. So my two factors here are x squared plus 1 times x minus 2. This is going to be the biggest thing to make sure you know what you're doing, and just put them together and then square both sides. That's the only way you can get rid of I, is by squaring it. Now we'll FOIL this out. X squared times x gives us x cubed. X squared times -2 is -2x squared. 1 times x is positive x, and 1 times -2 is -2. No like terms, so there is your function. F of x equals. Okay. Now the only way they can truly make this one more difficult is by giving you something with a plus or minus on it. Now we will do an example of that. Okay, this time they want degree 4, and the zeros are 2i, 3, and 0. Notice that directions is bad. I have to try and fix that in the notes before I type out the notes. A degree 4, zeros are 2i, 3, and 0. This guy here, remember, he comes in pairs. That's where the fourth one's going to come from. So if we were to set them up at x equals 0, x equals 3, and x equals plus or minus 2i. So these are set. This is just going to be x. This is going to be x minus 3. This is the one we have to work on. So I'm going to go ahead and bring these over. X minus 3, and then this guy. Square both sides. We get x squared equals 2i squared. Don't forget that both of these have to be squared. So x squared equals 4i squared. I squared equals -1. So this is x squared equals 4 times -1, or -4. Add the 4 to both sides, and you get x squared plus 4 equals 0. So our last factor, x squared plus 4. And then we have to multiply these out. So I'm going to go ahead and distribute this x over. So I have x squared minus 3x times x squared plus 4. So x squared times x squared gives me x to the 4th. X squared times 4 gives me positive 4x squared. 3x times x squared gives me negative 3x cubed. And negative 3x and 4 gives me negative 12x. Only thing I would ask of you from here is to put this in descending order. So f of x equals x to the 4th, which is the power we wanted, minus 3x cubed plus 4x squared minus 12x. And we're done. Okay. And then the next one is giving you that difficult one I was telling you to watch for. Find a polynomial function of lowest degree with rational coefficients that has the given numbers as sum of its zeros. So here's the one I was referring to. This is not 2 comma negative 1. This is 2 minus I. So we have x equals negative 1, which gives us the x plus 1. Hopefully by now that's the easy one for you. And now we have x equals 2 minus I. Oh, actually that's plus or minus I. What you need to do on this one is bring the real over to this side. So now I have x minus 2 equals plus or minus I. Anyways, isolate the I. Okay. Now square both sides. X minus 2 squared equals I squared. But I squared we know is negative 1. So we have x minus 2 squared equals negative 1. We're still not ready to bring it over with the x plus 1. We have to multiply this guy out. We have to expand him. But I'll give you the reminder since it's the first time in this video. If you have a minus b squared, you're going to get a squared minus 2ab plus b squared. So that's going to give me x squared minus 4x plus 4 equals negative 1. Add 1 to both sides, and we have x squared minus 4x plus 5. Put a little line here because this is really just a bunch of side work. So our other factor, x squared minus 4x plus 5. And now you're ready to multiply this out. X times x squared, x cubed, x times negative 4x squared, and x times 5 gives us 5x. 1 times x squared is x squared, 1 times negative 4x, and 1 times 5. So f of x equals x cubed minus 3x squared plus x plus 5. And there's your function from that one. Okay, so this was the last one of these ones. Do come in class with questions if you have anything on these. You may or you may not. So continue your assignment with this next set of problems. Here's 6 of them. I told you I was going to try and keep them around 5. Yesterday was 4. Today is 6. Average of 5. These problems, it has at least, I believe, 1 or 2 of each type of those problems that I just gave you. So there you go. Good luck on those.